All right, there is one change we're going to make because we're going to extend this due to time. I'm not concerned about it much, but we're going to be doing this from time to time, altering our calendar just a little bit. So if you want to make that alteration, I'm moving what was due on 4/12 to 4/18. We'll have time to talk about it in the next 2 days, but we're going to move it down to the 18th. Okay, so I think that'll help quite a bit, and I will get into how that works probably tomorrow, or for surely on Wednesday, how to do this. And again, you only have the odds, you don't have everything to do. So if you'd like to make that change, you definitely can, okay? You should have a packet. If you didn't grab one, please do so. We are going to go through a couple problems today. I'll explain it once everybody gets in here. But again, those of you that are just coming in, if you want to make that alteration in blue on your calendar, you definitely can. Okay? I'll wait about 10 more seconds.
I already gotta get my stuff.
At this, what's, what?
Because I was gonna leave because it's PLC.
Right, that's good. So, make that change if you'd like. Today what we're going to do is we are going to get into the beginning of what our reviews look like. So if you look at your packets that I just gave you, this is the beginning of your big packet. And when I say the beginning of it, is that your packet ultimately is due on the 2nd. It says AP exam review packet. We're going to take my huge stapler that can put like 60 pages together at once, and you're going to be putting all the ones that you get together. So let me explain how this works. So I'm very clear. There's apparently a lot of miscommunication. No, sorry, misunderstanding. There's no miscommunication, there's misunderstanding. Today, we are starting this. My goal, if I don't get through it, I will start where I left off the next day. We are reviewing 4 through 6. So my goal is that I will do the first one of each chapter. So every packet you get will have 2 from each chapter. So if you look at this one, there's a chapter 4, and on the back there's a chapter 4, and then there's a chapter 5, and another chapter 5, and chapter 6, and another chapter 6. I will try to do the first ones. You are responsible for the second ones on the next time we review it. So I will be checking, and you should have an honest effort at trying to finish those 3 by then. Where you do it is in the open space. Please do not cram it into the spots. That's why I have it designed this way, because you don't get to do that on the test. You have to formulate it A's and B's and C's and work your way down as you go. There is help for you in the resource room. I have the answers to problems based on year, and then you can find the problem on there. So you can definitely get some help. Should not be just blatantly copying these problems. When I go through here, like on the 21st, should be like, I just didn't understand that one. And you have like half of A started. That's not enough. And I will stamp the ones that you've completed, and it looks like you've given it an effort. Okay, so if you've given it an effort, a real good effort, great. We'll quickly review those, and then we'll probably be doing something else as well. So it's not like I'm going to go through those 3 in class. I'm going to just answer a couple questions, and then we'll probably do something else, like another problem that incorporates 1 or 2 of those as a review as well. So it's not like, oh, well, he's just going to go through all 3 anyway. That's not exactly how it's going to go down the second time. That second one is for you to work through and then like check the answer keys. And oh my gosh, that's how I worked through it. Morgan.
So try all of these by the 21st?
My goal is I will always do the first of them all.
Okay.
Your job is to do this. So you have to do 1 of each chapter, basically, on your own. Does that make sense?
Yeah.
Okay. So it's the second one of each chapter is due by the second time it says that review. They're all doubled up. Okay? So, that being said, we got to get going. So we're going to start the first one now. So, this one is about reactions. This is a unique one. There's not going to be nearly as much writing, so I'm going to try to do as much writing as I can, even though there isn't that much. So reactions can deal with a lot of things: solubility rules, activity series, signs of reactions, stoichiometry, redox. So we got to make sure we just kind of get back into the swing of things on that. So here we go. It says, the identity of an unknown solid is to be determined. The compound is one of the 7 salts in the following table. And oh, by the way, part of this is also learning where and how we get points. So as I go through this, I have the answer keys of how they graded it, so I can tell you like, oh, that was worth a point, this is worth a point, and things like that. So that's an important thing, I think, to understand. The tests are done in sequence from A through E. A, the unknown compound is white. In the table below, cross out the 2 compounds that can be eliminated using this observation. Be sure to cross out those same 2 compounds in the tables from B, C, and D. So we are looking for 2. It's really important. The year they did this, students messed this up because they didn't understand what they were doing. You are trying to cross out things that are not white. All right, the compound, we're trying to locate and identify the compound at the ending that they're trying to describe. So some of these, like, how am I supposed to know that? Like this seems like a lot of descriptive chemistry or things that I'd actually have to know in a lab. So when in doubt, there are some things that I can try to help you with. So usually transition metals, I'd write this on the side, transition metals have color. Not always the case, but if you were going to say something had a color or not, usually transition metals have a color. There's one that I need you to know. So if you look at this right now, I think that you could probably figure out which 2 we're going to cross out. And why, again, we're crossing these out, because we're trying to cross out ones that are not white. So these 2 would not be white. So now we have to go through, and then we have to cross them all off. And I know that's scary. It's like, what if I'm not right? I'm crossing them all out. Yep. What one? This one you have to know. Most copper compounds are what? Especially in solution. It's usually, I'm going to actually say a bluish green, only because, is there an E in that? We'll go with it. Most solutions are blue, but if it's a different charge, like copper 1 is a little bit of a green. But you should know that a copper solution is blue. That you should know. Okay? All right, let's keep going. It says when the unknown, I'm going to read from here because it's hard to read up there. When the unknown compound is added to water, it dissolves readily. In the table below, cross out the 2 compounds that can be eliminated using this test. Be sure to cross out those same 2 in the other tables. First off, just so you understand, this would be a point, that would be worth a point, just by crossing those 2 out. This is an amazing problem if you would know how some of these work. The points come out really easily without a lot of no calculations at all. So, what is it dissolves readily in water? Dissolves readily. I'm trying to highlight the thing I'm looking for here. So this one, although I did the 2, what was it actually? It was white. Where's the white? There it is. This one, it dissolves readily. And it says cross out the 2. Okay, so a couple things that we know. Any of them that you really feel confident, like no way that does dissolve. We've got to cross out ones that don't dissolve, so that they're not soluble. That they're not soluble. They're insoluble, let's just say that. That's what we're looking for. Okay? That's what we're looking for on this one. And usually you're going to do a lot of work on the right side. This one is a little more unique. Any of them that just jump right out, like I know that one's insoluble for sure. There's one that's like you should know. Wait, that is insoluble? Sorry, I was trying to, sorry, you're right. You were right, actually. What is one that's really soluble? One that you should know is soluble. My fault. This one for sure, right? Like alkali metal, right? All alkali metals, all nitrates, we should know that. Here's a little tip. So actually you're right about BaSO4. That is, it's an exception. But let's say you forgot that. Because oh gosh, I don't remember. Is there any clues in this one that's like, well, if I have to cross 2 out, and I know that one is really soluble, there's 4 of these left and 2 of them are not. Just look at the formulas ones. Yeah, they're attached to water. If something's really insoluble, how could water, they're not really great, not a really great relationship with water in the first place, and now you're telling me that they're bonded with water? You know what I mean? So, it would be these 2. As a reminder, their sulfates are soluble except a few, like BaSO4 is a big one. And then carbonates are slightly soluble. So if you could remember that, that's great. But if you didn't, this one actually you would be able to potentially get it right anyway. So it's 1 point for crossing out each of those. Now, they say additional. So if you could only cross out one of the correct ones, you only get 1 correct point. Okay. Let's see if we can interpret this. When AgNO3 is added to an aqueous solution for the unknown compound, a white precipitate forms. In the table below, cross out each compound that can be eliminated using this test. All right, so let's talk about this. When I add AgNO3, this is actually what happens. These break apart, and it's going to combine with something else And basically, which one of those two is going to be part of that precipitate? The Ag or the NO3? We should know that. The Ag, because NO3 is really soluble, right? So this is what I'm looking for, just to think about. That's going to be my solid plus something NO3. Okay? So let's look at what's left. I mean, if we truly look at, oh, sorry. I don't know if you did this. You got to cross out everything. Let's look at what's left. This is what we have. You have Al, you have Na, and you have Ba, and we have NO3. I didn't do that with the right one. Shoot. Doesn't really matter. We have Cl, and we have Cl. So, of the sides, which ones matter? These are the ones we're looking at, right? Because that's going to go with the Ag, correct? Positive and negatives. So you only have two choices, Cl and NO3, and we know that NO3s are really soluble, correct? So that can't be that one, right? So right away, it says it makes a precipitate, so I'm already done. Get what I'm saying? Like, it can't be, it's got to be a Cl to make a precipitate. We have to cross out the one that doesn't make a precipitate. So listen to this. This is interesting. 1 point is earned for crossing out AlNO3, or for crossing out the NiNO3 if you didn't have that crossed out yet. Like if you made a mistake and had that going yet. So again, you get simple point for that. So, 2 left. When the unknown compound is carefully heated, this is important, it loses mass. In the table below, cross out each compound that can be eliminated using this test. They say that only because of the fact that we only have 2 left, but maybe you had more left than that. So if it's gently heated and it loses mass, and the unknown compound is carefully heated, which one is not going to lose mass when you gently heat it? You're like, I have no idea. What? Why NaCl? Well, this is a salt also. If I gently heat it, that water is going to evaporate off. We did this in lab last year when we made desiccates. When we were talking about desiccates, we had these little crucibles, and you heated it. It wasn't an exciting lab, but it weighed less than before. And if you don't remember it all, then just make sure you understand it now. Is that a hydrate, if you strip off the water, it will slowly reabsorb that water over time. And that's why hydrates are really good in desiccates. So hydrate, if it ever has a hydrate, if it ever, hey, this thing was heated and now it has less mass, what do you think's going on with that? It probably had water attached to it. And you got to be aware, it says gently heated. If we go crazy on it, now we might be breaking off bonds that are actually part of the compound themselves. So it's got to be this. So that'd be 1 point for crossing that out. Last item, and we're done with this one. I want to make sure we at least get through part of the next one. It says, describe a test. This is important. These are the things that I'm wanting you to start remembering about Chapter 4. Describe a test that can be used to confirm the identity of the unknown compound. By the way, if you're going back through here, I'd underline carefully heated. Loses mass. Oh, both. And this one was a precipitate. We're trying to find the identity. Limit your confirmation test to a reaction between an aqueous solution of the unknown and an aqueous solution of one of the other soluble salts in the table above. Describe the expected results of the test. Describe the formula of any products. So this is the important part right here that I think a lot of students would lose sight of. So think about this. I have basically this. I know the hydrate's there, but that's not part of the reaction order. So what I want to do is I want to react it. It's telling me this. I want to react it with something else, one of the other soluble compounds. So FYI, I'll come back down. It's all of them. These could count. These 2 green ones that I'm showing you on a letter B cannot because they're not soluble. So basically I have Al, Na. It's not going to be itself, right? NiNO3 and CuSO4. Those are the compounds that I can get. Now there's a huge clue within this that can give it away. Actually, there's something that gives this away. But can anything react? And then what does it mean? Expected results, or how you can test. Where's the wording? How can you confirm the test by seeing a reaction? So there's evidence. So what kinds of things are evidence of a reaction that we've learned? Simple things. Like this thing happened, and, oh, I know a reaction occurred. Okay, maybe heat, precipitate, sometimes gas, right, if it comes up, and sometimes color change, like especially like in an activity series, the metals will change color. Well, in this case, I'm reacting this with something else here, so it looks like double replacement reaction, right? So double replacement reactions usually create a precipitate. So does anybody know which one I can react this with to make a precipitate? There's actually a clue within a different problem. Why? Yes. So if you couldn't remember that, this makes BaSO4 plus something else. Doesn't really matter. Why doesn't it matter? Because what it's saying is, the question is, what could you react it with? CuSO4. You're saying that it's going to create a precipitate. That's the evidence. And you're saying the formula, which is BaSO4. That's what it's asking for. And you get 2 points for that. 1 point is earned for describing a prediction, a precipitate, I mean. So you get 1 point for saying that a precipitate, now I would say more than just a precipitate. I would say that it would create a precipitate, which would be BaSO4. 1 point is earned for a correct identification of a precipitate that would form from that. Now, the beauty of this is if you got this wrong, you could, let's say you picked NaCl. Well, oh no, actually I'm out of luck on that one. Shoot, I thought there was silver in there, but that was added to the problems. But there could be a couple other ones, maybe. You're out of luck. Okay, I'm like, maybe you take the CO3 and you add Ba or something like that, but it's already insoluble, so you're gonna have a hard time reacting to that one. So, shoot. Well, if a different problem was set up, maybe there'd be another line that you could go down. I was looking, and there's not even another option on here, so that would make sense. So there's only 1 point for that part, and then 1 point for the actual formula. I believe that equals 8 total. That's usually common, between 7 and 9 points for a free response. Okay, so I'm not expecting to have that all down. This is about getting familiar with the style and some of the problems that we have. Okay, so your job by next Friday is, for example, to do the next reaction on the back. Okay, but let's not do that now. Let's jump to the next problem on chapter 5. So let's do gases. And my job is to do kind of an introduction, get us into this. Please do not do what I'm doing, which is writing by the problems. Please go to the right side now, make an A, do the problems like I'm doing. I just don't have the space. So mine's going to look like it's right there. I want the space. So now we're on gases 5, 2012, right? Is that what it says on the top? Okay, just so we're all on the same page here. That's the worst, is when you're doing this on the wrong sheet. I love gas problems. I think you have a really good shot at getting most of it right, and if you don't get it all right, you probably are doing a lot of the same stuff in the beginning or the end, and then maybe they'll throw something new in somewhere in the middle. But you have a good shot at least getting about 50 to 60% of it correct almost every single time, which is good. Like that's okay in the long run. Obviously, we want to do more, better, but here we go. A sample of pure gaseous hydrocarbon is introduced into a previously evacuated rigid container. That's a volume. The pressure is at that. That's a P, and that's a T. This is screaming ideal gas law. Screaming. A, calculate the moles of hydrocarbon. So, I would do this to the right. You don't have to redo this, but I love if you can do that. It just sets you up better. I need N. There's nothing else I can say. They're going to start you off pretty soft. They're going to get you started, get you going. I love when they ask for an ideal gas law. It's always worth 2 points. 1 point is the work in the right spots with the units in the formula, and then 1 is the answer with the correct units. So that should be, we should be good to go. So I set this all up correctly. I struggle with showing or not showing the R value units. I think if I was on an actual AP exam, I'd probably consider showing it a little bit more, but if you're showing all the other units, I think you're going to be fine. I really do. And today I'm going to, just because of the shortened hour, be more of a calculator today. So that's the number of moles. So that's letter A. By the way, just so again you know, this is worth 1 point, and that's worth 1 point. The whole setup with all the numbers in the proper spots. 1 point is earned for the correct setup. 1 point is earned for the correct numerical answer. There we go. That's how I start. If you don't write it in scientific notation, it's not wrong. Notice 3 sig figs. We're in 3 sig fig land now. We want to try to do that as much as possible. There is one problem on the test somewhere that is going to grade on sig figs. You don't know which one. So if you always just do 3, you'll be safe. And I know it's only worth 1 point, but it's 1 point I don't want to lose if I were doing it. B, O2 is introduced to the same vessel containing the hydrocarbon. After the addition of O2, the total pressure of the gas mixture in the vessel is 1.4 atm. And then they say a temperature. Don't freak out about that. They're just establishing it's the same condition. They do that all the time. Calculate the partial pressure of O2 in the vessel. Okay, so think about this. You had a hydrocarbon, it was 0.2. You added oxygen, now it's 1.4. This is just Dalton's law of partial pressures. What it's simply put, you don't have to write this, but I think it'd be good to just have, is that the total equals, we're going to call this the hydrocarbon plus the oxygen. That's all this is. We do all this because we need to see this again and get familiar with, oh, that's how that one works. So this is how I would set this up. Right, but when it's all said and done, I have 1.2 atms, correct? And that's all that is. And I'm going to assume this is just 1 point. I cannot imagine that's worth. Yeah, that's all I want. That would be ridiculous to be more than 1. Okay, so they're just establishing something with the pressures of some different gases and things. Then it gets tricky. Now, I did it differently last hour than I'm going to do it now. Last hour, I'll talk about how I did it. There's 2 different ways, and even the answer key does it in 2 different ways. One way is a little longer than the other. They both go in different patterns. So let me read what it says. This gets a little tricky. Once in a while, you're going to run into something. Do the best you can on a problem and move on. If you feel like you didn't get an answer from it, but you feel like, here, on the basis of your answer above, like you might need to, say, assume. But in this case, it says write the balanced chemical equation. Well, okay, that's not necessarily a complete calculation. We'll talk about that in a second. The mixture of hydrocarbon and oxygen is sparked so that a complete combustion reaction occurs, producing CO2 and H2O. The partial pressures of these gases at that temperature are those 2 atms for CO2 and H2O. There is O2 remaining in the container after the reaction is complete. So let's talk about this. Again, you're going to do this to the right. I have a hydrocarbon. I don't know what it is. Okay? It's reacting with oxygen. It's producing CO2 and H2O. Now, I did this in 2 different ways. I'm going to eventually. In the beginning, I'm just going to map this out once. I had this, and I had this. After, I know this looks kind of like an ice box, but it's not completely. I'm just organizing information, if anything. I have this, and I have that. And if this is as far as we get, I'm okay with that for today. We'll finish this up. It goes fast, and the next round's really short. Okay, so what's the whole point of this? Here's the thing you need to understand. What I needed to try to teach you today is that the CO2 and the H2O all stem, the amount of oxygen comes from that, right? That's the only source it has. So when I'm making CO2 and H2O, that's where I'm getting the oxygen from that. So there's a couple ways you could do this, but the ratio is all I care about. Last hour, what I did is I plugged in, I actually did this for both, and I found this, and I found this, okay? And then after I got the moles, then I'm going to do what I'm about to do now, which is I found the amount of moles of O2. And I'm going to show you this part right now. And then I added up the moles and I plugged it into a new, what are we looking for? Pressure equaling of O2. I'm just writing this on the side. Let me show you what I'm going to do this time. And you're like, wow, that's a lot of work. That's where my brain went this time. I'm like, well, I don't know. I have the pressure of these two. I'm going to figure out what I have, how much I have of it, and then I'll convert it. Because you have pressure, do this with me. I'm going to take this 0.6 atm, and I want to label this, and I'll do both right away, so we can kill 2 birds with 1 stone here. Pressure is still a ratio. Pressure is a ratio. It's the pressure in a certain volume. There's a ratio there. So what you can do is basically use pressure like moles. You can basically use pressure like moles. This is why I kind of chose to do it the other way the first time around. So let's just talk about this. And hopefully this part makes sense. Okay, if I wrote moles, I think it makes more sense to you. But if I had one of these, if I had one ATM of this, let's just say, but let's say that was moles, just in your head. How many moles of CO2 would I have? Well, I have 2 oxygens here, and oh, there's already 2 oxygens there, right? So it would equal whatever the pressure of my oxygen, that's how much can go into that amount of oxygen there. So it's a ratio of 1 to 1. If you're like, I don't know what just happened, the bottom one will show it. If I had 1 ATM, that's why I don't like this one as much, of O2, how many waters do I need to equal O2? Just look at the oxygens. I need 2. I need 2 of them. Stay with me. What I like better, but it was longer, and I was seeing if I could buy some time. So, because we're not going to do any more problems. I know we only have a minute left. Just take a look again. You could easily plug these numbers in if you want to try this later. If I did the P, which is this pressure, the V, which is 1, the R, which is normal, and then the T is the 400, and you got the moles of O2, okay? And then I took the moles, the moles of water, and then I put moles of water here, and then I did the exact same ratio, and then I got the moles of O2, and then I got the moles of O2 from the CO2. I could just plug in the total moles and then redo another ideal gas law. Either way, it's trickier. You get 1 point earned for the correct stoichiometry consumption. So regardless, if you did stoichiometry showing the 1 to 1 or the 1 to 2, that'd be worth a point. And then you get 1 point earned for the correct final answer. What I want you to get out of that and try to start remembering, though, is this is what's tricky. You guys actually had to do this on your semester final. Is that when you don't know the ratios, and we're going to figure out the ratios starting class tomorrow, then you got to realize all that oxygen coming from in CO2 and H2O all come from just that oxygen there. And we can do ratios. So for every one of these, I have one of these. For every one of these, I only have half of these. So I need 2 of these equal 1 of those. And well, I'll show you how it finishes up. Your goal, your job right now, finish up your nuclear. That should be done. If not, get it done. Start looking at the second ones if you'd like. Start looking at the second 4. Start looking at the second 5. If you don't even want to touch the 6 yet, that's fine. But stay ahead of it. Realize every day we're going to be talking about another part or finishing that packet or beginning another packet. But then you have time. You're not having any other worksheets, okay, besides a couple of reactions, and those are mostly odds. So if you're like, man, we got a lot of work. You have no other worksheets. So it's like, it's probably about the same amount of anything else.
I have a yellow sheet.